This system of equation has fractions in there, and I'd really like to get rid of them. So for the top one, the least common multiple of the denominators is 6, so I'll multiply both sides by 6. We need the least common multiple of 3, 4, and 2, and that's 12. Distributing this through, we'll get x minus 3y equals 36, and distributing the 12 through, we get negative 4x plus 3y equals negative 9 times 6, which is negative 54. Now we need to decide what method to use to solve it. We could do elimination, since we have a negative 3y and a 3y. We could also do substitution, since we have x by itself. It'll be smaller numbers if we do the elimination. So let's add these two equations. We get negative 3x plus 0y equals negative 18. Divide both sides of that equation by negative 3, and we get x equals 6. Now that we have x, we need to find out what y is. We have several choices of where we could plug in x to find y. We could use any of these two original equations. We can use these two also. The one that looks simplest is the x minus 3y equals 36, so let's do that. Let's check our answer. We need to check the answer in the very original equations before we wiped out the fractions. That's in case we made a mistake when we wiped out the fractions. So plugging into the first equation, we get that it works. Now the second equation, that also checks. Notice I was working from the left side of the equation and simplified it until I got the right side of the equation. So our answer is the set consisting of the ordered pair 6, negative 10.